Hi everyone, this is Rakshita BK studying at Sri Venkateshwara College of Engineering in the Department of Electronics and Communication. Today I am going to explain you about the transport layer security. Now let we see the introduction. Transport layer security is a cryptographic protocol designed to ensure that secure communication over a computer network. It provides confidentiality, integrity, and authentication by encrypting data transmitted between the parties, preventing dropping, tampering, and impersonation. Transport layer security is widely used in applications like web browsing, email, instant messaging, and voice over IP. It builds on its predecessor secure sockets layer, offering improved security and efficiency. TLS operates between the applications and transport layer of a network stack, ensuring that sensitive information such as login credentials and financial transactions remains protected during transmissions. Its adaptations has become a cornerstone of modern internet security. Next, we'll see transport layer security is a cryptographic protocol designed to provide secure communication over a computer network. It ensures the privacy, integrity, authenticity of data exchange between applications and users. Now, we'll see the key features of transport layer security. First is encryption, how the data is encrypted. Data that is, transport layer security encryption is a fundamental mechanism that ensures the confidentiality and integrity of data exchange between the parties over a network. It uses advanced cryptographic techniques to encrypt data, making it unreadable to authorized entities. The transport layer security employs asymmetric encryptions during the handshake phase to establish a secure sessions and exchange keys. Once the session is established, it switches to symmetric encryptions for efficient and secure communication. This dual encryption approach prevents data interception, tampering, and impersonation by encrypting sensitive information such as login credentials, payment details, and personal data. Transport layer security safeguards use privacy and protects against cyber threats, making it an essential component of secure online communication. Next, second is authentication. Transport layer security authentication is a crucial process that verifies the identities of the parties involved in a communication. This is typically achieved using digital certificates issued by trusted certificate authorities. During the transport layer security handshake, the server presents its certified to the client, providing its authenticity and ensuring the client is connecting to the intended server, not an imposter. In mutual authentication, the client also provides a certificate to validate its identity to the server. This authentication mechanism prevents man in the middle attacks and establishes trust between the communicating entities. By ensuring both parties are legitimate, TLS authentication plays a virtual role in sensitive transactions and protecting against unauthorized access. Third is integrity. How the integrity is worked over the transport layer protocol, let we see. The transport layer's security ensures that integrity by preventing unauthorized modifications or corruptions of message during transmissions. This is achieved through the use of cryptographic hash functions and message authentication codes, that is MACs, which are applied to the data before it is sent. The recipient verifies the integrity of the data by comparing the received MAC with the computed value, ensuring that the message has not been alerted or tampered with its transit. Transport layer security also incorporates sequence numbers to protect against reply attack by maintaining the integrity of transmitted data. Transport layer security guarantees that the communication remains trustworthy, reliable, and secure, which is essential for sensitive online transactions and interactions. Now, how the transport layer security will work. First is handshake process. That is, the transport layer security handshake is a process that establishes a secure connection between a client and a server. It begins when the client hands a client hello message of the server specifying supported encryption algorithm. Transport layer security versions are another preferences. The server responds with a server hello message, select compatible options and providing its digital certificate, which includes its public key and issued by a trusted certificate authority. The client verifies the server's certificate to ensure authenticity. It's verified. The client generates a pre-master security and encrypts it using the server's public key, sending it back to the server. Next, we'll see the data encryption. Transport layer security ensures secure communication by encrypting data exchange between a client and a server. After the TLS handshake establish a shared session key. This key is used for symmetric encryption, encrypting and decrypting the information. The encryption process ensures confidentiality, meaning that even if a data is encrypted, it remains unreadable without the session key. Transport layer security also ensures integrity using message authentication codes, which verifies that the data has not been tampered with during transit. Next, we'll see session closure. Transport layer security ensures a secure and orderly end to a communication sessions through a process called session closure. When either the client or server decides to terminate the sessions, they initiate the closures by sending a special close notify alert. This message informs the other party that no more data will send and signals that intended to end the session securely. Upon receiving the close notify alert, the recipient acknowledges if by also sending a close notify alert. After this exchange, both parties close their connection and discard the session keys, ensuring that no future communications can occur using the same session. This prevents any potential vulnerabilities such as reply attacks or unauthorized data transmissions after the session ends. Next, we'll see common uses of transport layer security is security websites, encrypting emails, protecting voice and voice calls, and safeguarding file transitions transfer.